And hi, Professor Chen. This is my second video for this week. This video is about question 2. Let me introduce this question first. The random variable x is uniform in the interval from the -1 to 1. So find gx such that if y equal to gx, then the probability density function of y equal to this part, the e to the -y multiplied by the uy. And the uy we've already learned that is unit step function. It means when y greater than 0, the uy should be 1, and otherwise the uy should be 0, which means when y less than 0, the uy should be 0. And the random variable x is uniform in the interval from the -1 to 1. So the variable x is uniform. It follow the uniform distribution, so we can just simply find its probability density function in the interval from the -1 to 1. So it should be like this. And this is the x probability density function when x located range between -1 to 1, and otherwise fx should be 0. And we already know the probability density function of x and y, so we can just draw the probability distribution function of x, y from these two functions here. And so the fxx equal to the probability distribution function of x. When x greater than 1, this fxx equal to 1, and when x located range between the -1 to 1, it should be 1 plus x divided by 2, and fxx equal to 0 when x less than -1, and the fyy should be 1 minus e to the -1 when y greater than 0, and otherwise when y less than 0, the fyy should be 0. And we want to find gx so that the y equal to gx, then the fyy equal to this part. So y equal to gx, so we can just transform this equation to the other form, which means we need to write based on this equation here, we need to write another equation that use the function y to describe the x, the variable x. We already know the fyy from the definition. The fyy equal to the probability when y less than y, and we can just use this. We can just use what we have concluded here to find that fyy actually is equal to the fx g to the -1 y, which is the inverse function of y, inverse function of gx here. So we can just use the corresponding relationship here to find what gx is by using this equation. This part is equal to this part. So when x located range between the -1 to 1, the fxx should be in this part, and we need to use this to equal to this part, because we need to find the relationship between the x and y. If we use this equal to this, it makes no sense. So we just like this part equal to this, so we can find the gx in the range between the -1 to 1. It should be like this. This is gx, and then we should use the fxx equal to 1 when x greater than 1 equal to this part. We need so we can find what would y look like when x greater than 1, and we also to use this to equal to this part, because we also need to we need to find what y looks like when x is less than -1. As I said before, we use 1 equal to 0 or 0 equal to 0 is make no sense because we need to find a relationship between the x and y. So we need to use the 3 part of x, y, y equal to this. Y greater than when y greater than 0, f y y equal to 1 minus e to the negative 1. So we can find that when x less than negative 1, 0 equal to the 1 minus e to the negative y, so y equal to 0. And the other part is y equal to the infinity, positive infinity. So finally, we can conclude that the gx should be looks like this. And that's all. Thank you.